today's session, we will again start with the MEP. So, in the previous sessions, we have already taken the MEP plumbings and we have seen how do we do the plumbings in Revit. So, in today's session, we again go back to learn MEP. So, in the today's session, we will learn the electrical part. So, let's start with the previous models only, in which I have taken the system template. As you have all remember, like we have taken system template because we want to work multiple disciplines of MEP in one project only. So that's why in system template automatically all the views are previously set up from the software, like from the Autodesk end only. So you have all the electrical, mechanical and plumbing views set up already inside the project. Now for electrical, we have two different types of plans. The one plan is lighting and another one is power. So basics you can understand, like the lighting means the light appliances devices, like the all the different lights. Even though the fan units and all the small units, like which is not having so much power consumption, so those units will come inside the lighting plan. But in power plant, generally we have to provide the sockets, the receptacles, which is having the higher voltage cap, which will take a lot of power to like which requires more power. Okay, so basically in the power plant you have to show receptacles. See, we can show the units as well, like the AC units, the geyser units, but that depends on the project scope. So if suppose the client only required the receptacles, it means socket points where they want the power units to uh, like connect. So those things they just show in the power plant. But sometimes some of the clients require the overall plan, like they want all the AC unit exact location, geyser unit, dryers, like everything. They want it to be shown in the plan. So that time, again, the power plan is only used, but basically they have to show uh, the family fixtures as well of electrical fixtures. Okay, so it depends project to project. So let's start with the lighting plan. So in general, there is floor plan and ceiling plan. So lighting plan generally we will work in the ceiling plan only. Okay. So let's start with the ground floor ceiling plan. So as you open the ground floor ceiling plan, you can see the ceiling and the floor. Also in 3D, when you will go to the 3D, you can check the ground floor ceiling plan. Actually, first go to the elevation so that you will understand the exact location. So right now we want to go to ground floor ceiling plan. So actually this one is zero level. So ground floor ceiling plan in generally it will come over here. Okay. But the view range it's not showing exactly right now. It's showing the above ceiling plan. Okay. This is like uh it's showing the correct ceiling only, but the thing is it's showing exactly on the floor, which I don't want. I want it slightly below. See how the view range will work. See, I have taken this in very early days of the sessions, like what I have told you, how the view range work for the floor plan. For the floor plan, when we are working in the floor plan, we are seeing the above from the top to the bottom. Okay. For the floor plan, when we are working on the floor plan, normal floor plan, so what we are seeing from the top to the bottom floor. But when we are working in the ceiling plan, what we are doing, we are seeing the ceiling from the bottom. Okay. So in this way, we are seeing the ceiling from bottom to the top. So obviously, when we are seeing the ceiling is completely fine. But right now, we are also seeing the roof, not the roof, like the first floor slab we are also seeing, which we don't want. We want it to show little below so that only the floor will be visible. Okay. So what I will do, I will go to the view range. So as of now, when we are working in the floor plan, we are seeing from top to the bottom. But right now, in the ceiling plan, we are right now seeing the from bottom to the top side. So the top side, we don't want exactly on level 1. We want it to be little low. So how much low? Suppose minus 300. So the top will be low. So view depth of the top also I don't want to be at that much high. I will drop it. Let's see. So now you can see exactly the ceiling, but still some of the sunken slab is visible. So maybe we can bring little more also. Okay, now it's completely fine. We are not seeing the slab inside. We are seeing only the ceiling area and inside the floor. Okay, so right now if I'll go to the elevation, so earlier the ceiling plan, it was somewhat here so that all the slab things are visible. Now we are just little below. So right now we are somewhere here and we can see easily all the ceiling elements. Okay, understood? In the ceiling plan. Now our task is to provide the ceiling light. Okay, we have to provide the switches. Okay, and also we have to provide one panel. Panel, what is the panel? Panel is basically a appliance box which will connect to the electrical DG generator. So that is having the power to connect with all the electrical appliances. So basically we'll place a panel board. So in the architectural plan, you have to decide one area. Suppose this is the building entrance area. So somewhat near the stairs area, I am providing one panel board. You have also seen in your home, like there is one panel unit, like all the different uh, what we call
CV, sir.
meters and meters. Yeah. So MCV and all everything will be placed in one particular area, right? So basically, we'll provide only the panel board so that client will understand like where we have to fix all the panel elements. Okay, and from there we have to select all the. Let's do one by one. Okay, so first thing first, we'll place some lighting fixtures. So in the system tab, you have electrical. Okay, so in the electrical, these many options are available. Okay, so in these many options, you have to place the uh, let's first place the lighting fixture. So in the lighting fixture right now only the ceiling recessed fixtures is loaded, which I don't want to show in this project. Actually, this type of recessed ceiling light is used for the industrial buildings like commercial places. Okay, big commercial malls or something. There they will use this type of lighting. I wanted to be simple round shape ceiling light to be used in our project. So let's load some of the family. Okay. So we'll go to the template, no, the family lighting. Okay, so in the lighting you will see. So now there is two options, architecture and MEP. What is the difference? Sometime the architectural team will use some family just to show the placement of the lightings and all. So those families are architectural family. So it is not having any power connection. But MEP team will have the MEP folder, and in the MEP folder they have the electrical lightings which is having actual lighting connections available. Okay. So I have already explained you in previous session, like families are very simple. Any family, when we will connect the connector, so that will change from architectural family to the MEP family. Only the connector is the difference, because connector is having certain data that will allow you to connect with actual MEP appliances. Okay, so let's select one. So there in the lighting also there is two types of lighting. External lighting means exterior side, like street lightings and all. But internal lighting means building in-house lightings. Okay. So those are like, so this type of lights are there. Wall lights, recessed light. Also, if you want, I will select all for now. Okay. Maybe some of the family. I forgot the exact name. So let's select all and open. Okay. So now you can see these many lights are available. All the different types of lights now we are having, but we have to use ceiling light, flat, round. Okay, M ceiling light I will use basically. Okay, so for suppose this is a bedroom, so I will provide on four corner. So right now in the architectural plan, I have already drawn this ceiling. Just need to select the face and click it over here. Select it on the mid of the ceiling. Okay, and one light for the also suppose in the toilet, if you don't have ceiling, you can provide separate type of light, but you have to check which type of light is suited for, like it will be okay for your project. Let's check. Suppose for the mirror I will use suppose wall lamp. Actual direction I need to check it in 3D. It's correct or not. It's not correct direction. Yeah. So need to think like what type of light you have to provide. Also, this is kind of LED light, strip light. That also you can place it in instead of that wall lamp light. So this one also you can place it near to the, this I will remove. So this is also you can place it near to the mirror. Okay, let's place it on the right. Okay, right now it's on 0. We have to bring little more because sink is right now here. So at least 1 feet I will provide, or 600, because it's just above the, suppose there is a mirror, so it's just above the mirror, so that lights will be there. Okay, and suppose one ceiling light inside the toilet I will provide. Okay, now one more lights can provide it over here in the sitting area, one or two light. Okay, so all the lights I have placed. Now let's place the switches. So you can see near to the lighting fixture there is a device. So in the device there is a lighting option. So basically it's a switches. So you can see these many different switches are available. So there is one-way switch, there is a three-way switch, even the two-way switch is also there. So when you require to place lights, switches for two places, like suppose you want to control switches from the door end, also near to the bed area, so that you can place two-way switch. Okay. Also click the plan view to find, so that you can see that switches are placed. You can see right now the switches are placing on face of the ceiling, which we don't want. We want it to be placed vertical. Okay, which will embed inside the walls. Right now it's 1200 above from the uh, floor plan. So let's provide over here and think one over here, and one is again over here. Two switches over here as well. Okay. Now let's provide one-way switch. This is two-way switch. Okay. Let's provide one-way switch for this light. Okay. And another one switch for this internal, this one. Okay. Apart from that, if you want to add receptacles, that is socket for the plugins and all, so that you have to show in different plan, that is power plan. So that is different plan. No need to show it in the lighting plan. Okay, understood? Also in the visibility graphics, make sure to check everything like electrical equipment, fixture, Because in lighting plan, basically these two things are not visible. Okay, but we can show, depends on the uses. Now we'll place the panel, but before that we have to load that one. So electrical equipments, load family. Some panels are there, but that is not standard one. I will load more panels. So in the electrical, earlier I was in lighting folder. Now I have to jump into the electrical folder. So in the electrical, go to MEP. Then you have electrical power, and then you have, see, these many things are there. There is transform transformer. Okay, terminals, distribution appliances are also there, like fan, hair dryer, hand dryer, heater. So some appliances are given. If you want to add, see, this type of, it's just shown a representative element. It's not like a good fan family, but what you can do, you can download some of the fan, architectural fan, and you can place it in this so that it will become exactly like the fan family. Okay, this is just a representative family. Okay, it's not actual fan. Now go to the distribution. Actually, we want to add the panels. So lighting panels, I will add. Okay, so these many panels I will add first. Okay, so I think this one is okay. M lighting appliances surface. Okay, see, written over here MCV. So all looks same only, but there is certain uh, ampere which is required to generate electricity. So actually, those things will be, you will get it from the architectural designer. Your task is to just learn the connections, how to do it in the Revit. So those things only you can focus. Other than that, the design elements, what are the values and all, those things just need to, uh, that values and all, that will be provided from the electrical designer. Okay, so those people will tell you like what distribution system required, what different lighting units, like is it required 60-watt lights? Nowadays 60-watt lights are not used. It's like 10-15 watts light only. Okay, even the LED light nowadays is like 5 watt also. So that depends. Those things, these are like the older families, right? So those things will be provided from their end. So based on that, the loads and all, you have to change it in your project. So right now our focus is to just learn the connection, how to draw the plans for the electrical. Those things only we are looking, right? So what we have to do, first select these four lights. Okay. And we have two options. When you will select these lights, we have two options. One is power, one is switch. So make sure select all the light at first, okay, and provide the power. So once you will select all the lights and you have selected the power, now there is one option whether this, right now the line work it's showing like these all are connected in one, and now you are correct connecting this circuit into the panel. So basically, the dashed line, it's basically the temporary line. It's temporary line. So what will happen? This dashed line, you have to make it permanent also. To show it exactly like a wire, you have to make it permanent. Otherwise, when you will click outside, this will be gone. Okay. So that I don't want. So you can bring it back again, pressing tab. So select tab, you will see the dash line again. Click on any one of the appliances. Again, you will get into back into the modify tab, and you have the option to create a wire. So basically two type of wire you can create in Revit. One is arc wire and one is chamfered wire. So it depends on company to type company, like what type of representation they want to show. So bigger projects, it's recommended to show chamfered wire, means the straight line wire. But in smaller projects, we will show the arc wire, which will looks good and it will be more visible. Okay, so arc wire, when you will select, automatically all the dashed line will become a wire. Okay, once the wire diagram is complete, so basically these lights are connected in one circuit. Now the focus is to select all the lighting again. Okay, or what we can do, yeah, you can select, pressing tab, select all the lighting. Make sure you will select all the lights only, and then you can see earlier we have provided the power. So power diagram, basically it's created with the help of this line wire diagram. Okay, that will be here in the electrical circuit. So in the electrical circuit, you have one option to edit the circuit. Basically, if you want to remove certain lights from the circuit, or you want to provide two separate circuits. Suppose this side all the lights you want this separate circuit, and this side all the light you want separate circuit. So that you can do. Okay. So what you can do right now, you have to select the panel. So right now you can see the panels are not visible. Why so? Because the distribution system will not allow this much ampere. So maybe we can take 400 ampere. Let's see. Maybe we can change the panel. I will take this one. Let's see the difference. No. 80. There is 280. Surface. Okay. Then. So actually, I'm changing the voltage. Basically, these all lights are connected when inside the panel only when the volt will match. Okay. So now let's see. Yeah. So you can see the now the panel will be shown. Until unless the panel will not show, like you have to change the panel board which will match the this lighting fixtures. Okay, so once you will select the panel, now it is showing like this is connected. Okay, so basically now it's connected to the this panel board. Okay, so tab, now you can see when you press first tab, it will show the circuit diagram of the lighting. Second tab, it will show the connection of this circuit diagram with the panel. Again, you can draw the wire. Okay, and this wire right now it's showing very small, but what you can do, you can bring it up to here and you can draw the chamfered line diagram, like little twisted, so that it looks better. Understood? It's just a representation. No need to show exactly like on the panel, but you have to show like it's going on the panel. This wire is going on the panel like that. You can show, or even you can connect it also, no problem. Understood? Even you can change the position of this wire from here to here so that it looks like from here the connections are connected in this circuit. Okay, understood? So after this, what you can do, you have to connect all the, see, powers are connected, but until unless the switches connections is not connected to the lights, you will not break the circuit if you want at any time. Okay, so what you have to do, you have to select the switches or you have to select the lightings. Suppose these two light, I want to give the right side switch. So select the switch now. Select the right switch. Okay. Let's see the, let's select the lights again. Go to electrical switch. Select switch, the right one. I think now it's connected. Yeah. Now for the wire, for the switches, the wire line diagram you can't show. See, you can't show because it's not required also. You just need to place the switches and you just need to connect the switches. So how you are connecting? Select this two switch and select these two lights. Click on switch. Okay. Again, select this two switch. Go to electrical circuit. No, go to switch system. Select switch. Okay. And then select this one switch. Again, select switch. This left switch. Okay. So two-way switch we can provide. Actually, connections are not necessary because see the wire line diagram you can't show it also. So it's just a representation that these two switches are controlling these two lights. These two switches are controlling two lights, and we can show it in the plan view. This two means two-way switch, and this is the representation of switch in 2D plan. Okay, now connect this switch with this lighting fixture switch and select switch, this one. Okay, same way, select this light, switch, select switch, the left one, the right one. Okay. For these two light, we want to show another switches. So let's place another switches over here and select these two lights. Switch, select switch, click on this switch. Okay. So all the switches are connected. Pressing tab, you will see the switch connections. Okay. And obviously the wire line diagram for switch is not required. Only the circuit line diagram for the lighting fixture you need to show. So this is basically the lighting plan you need to work on. Understood everyone? Is there any problem? Anyone is having any issues? No problem. See, now the plan is showing the wire line diagram. In one another plan, if you will, I will duplicate. We have to show some of the plan conduits. Conduits means how exactly the wire will be going on. Okay, like I will show you the plan. I will draw one section. See, the connectors is showing. Draw conduit from the face. So you can draw anytime the conduits from this electrical fixtures. Go to the section, draw conduit. Just a second. Hello. Yeah. So you have to show the conduits. Actually, you have seen in your houses as well, right? How the conduits are drawn. So kind of plumbing only, like you have to draw all the pipes, but obviously these conduits we have to show dia right now. It's too much. We can decrease the dia. We can load some of the bendings and all, and you can draw anytime, whatever the line, and then you have to show like how these instead of wire line, we have to draw all the basically we need to provide the so this is RNC, so we can provide the PVC pipe as well. So depends. So these joints and all we can load. Still, this is not good. So that we can load if you want. Conduits. This is little more okay. So basically, you can fit whatever you want, and also you can change the bend radius. Actually, these are families only. So anytime we can have any different type of families required, so that we can also do. We can provide this type of connections as well. Okay, this looks standard. So see, any type of conduit or any type of pipe, you have fitting option available. So on the bend, what type of fittings you want. Okay, so those things you can change it anytime. Suppose I want to give this aluminum standard L. So go to the fittings, bend you can change. This aluminum standard L. Okay. On the T also, suppose all place I will give aluminum. When T junction will be there, when junction box. Okay. So and on the everywhere I will give the aluminum. So what will happen? Like wherever we will draw the conduit, suppose I will delete this one, I'll trim this too. So automatically it will take the aluminum junction. Okay, that will require less space only. But if you want the PVC one, then you have to create a family that will bend less only. That will okay. So if required, that one also you can show. No issue. It depends project and also based on the engineers what they want. So no need to just show the conduit near to the switches. That's all. No need to draw any inside the switch. It's just a representation. So you can just bring it down. Basically, based on this, what will happen? You can get the quantity. Obviously, in the small project, you can easily calculate the length and all, but in bigger project, you need the quantity, how much conduits and how much junctions, every elements, you will get the easier data. Like once you draw all the things, you can take the schedule, normal schedules. See, already the schedules are provided. These are the analytical schedules, but you can create new schedules and quantities. We can take the schedules for conduits. We can take the schedules for even the fittings, how many fittings required. Suppose conduit, I will select. So obviously you can select the first thing first is family and type, then length, and then dia, and also you can select also if you require type or something, those things you can select. So anytime we can select the dia and whatever the length. So those things you can get it from the schedules. And then you can also calculate total. Suppose you want the total length, so you can calculate total. And in the sorting and grouping, you can give the grand total. So so that you will have all the length. Okay, right now all the same dia, so you can have only one conduit, right? If suppose we have different diameter also, so that time you can create another that time you can have another grand total. Like grand total will calculate all the length, right? But that time you have to do this one option, sorted, and then again you have to select the same length. So what will happen based on the sorting, also give the footer. So one particular dia, so sorting based on dia I will give. particular dia, you will have the total, and then you have another grand total. So suppose there is two type of dia, then you will have separate. I will show you. Don't worry, I will show you. Suppose you have another conduit with different dia. Suppose actually I have given 63. This is very big. In general, 10, 12 mm or 15 mm, 16 mm dia. Conduit is only given 20 mm. More than 20 mm is not required. Actually, these are like industrial diameter right now. Okay, that's why it looks bigger. This one 16 mm. So now you can see we have 116 mm. That one is total 2900 mm length, and other 20 mm dia is having this much length. So grand total is not required in this scenario. We required only the total of 20 mm dia, this much length. Total of 16 mm length is 2900. So okay, like that you will get the total. Now once you have the total length, and you know, like in like market you have like 10 feet or something, that much length you are getting. So how many number of pipes are required? That you can easily calculate once you have the model, right? Like you can divide and you can get how many number of 10 feet conduits are required for 16 mm, 20 mm feet. Also, this is the conduit length schedule, right? We can another create another schedules, and we can get the conduits fittings. Again, family and type, then type or size or whatever. Okay, description or count you want. Okay, so if suppose this is used twice or thrice, it will show the count as well. So how many number of these particular family is required in your project? You can get it very easily. In the sorting, you can itemize every instances, or you don't want to itemize. So this family is used only right now. So this is three. If suppose any T junction or all is used in your project, I'm just giving the example. If suppose any portion, suppose this one is T junction. Okay. Now you can see the schedules for fittings based on family and type. Okay. So there is basically two elements of this L shape, and one is T junction. So that's how you will get the exact quantity. So right now it's a small project, so obviously these values are less. And we are working in bigger projects, you will get hundreds or two hundreds of elements. Then that time schedules are very much important. Once you have created the schedule, automatically it will be like update all the elements while working also. So before also people used to do like create their template, and we will create all the schedules at very first only, and then we are simultaneously working so that we will get the exact data afterward also. Okay, even the switches, everything, you can create the separate schedule. So those things I will not go that much detail also, like obviously that you can now understand, right? Like for switches also we can create a schedule, even for the receptacles. So same way like the lighting fixture we have done, we have to just go to the floor plan of power plan, and then you can place the receptacles near to the switches, and same way you can connect it with the panels. Okay. So right now it's a lighting panel. You can place another panel near to it, and that will be the power panel. So those things you have to take looks inside the, or maybe you can create another system. Right now only one distribution system. So you can create another system that also is available. See, inside this system tab of electrical, you have the drop down electrical settings, and you can see these are the distribution system right now available. So based on the requirement, you can add another distribution system, and that distribution system may be for the powers. Okay, so everything you can do based on the engineer's data. Like no need to do it from your end, because obviously these things like comes from the engineer end. Okay, so you will not fill from your own side, right? So just need to learn the basics of Revit, so that once the engineer will give you the data, you can easily work on it. Okay, understood everyone? So this is the electrical. Same way, same way you can do it for the mechanical as well. Okay, so mechanical equipments, like you have to go to the HVAC. In HVAC, see the plumbing fixtures are visible, and that is not required. So what we can do, we can go to the visibility graphics. You can turn off plumbing equipments or fixtures. Basically, sometime electrical heater and all is visible. So that time it's very much important. But this obviously sanitary and these are not visible, then it's better in the HVAC plan. Otherwise, already so many things are visible, right? So let's place any mechanical equipments. So this is a VAV units. So VAV units generally placed outside somewhere in the building. Okay, and then you have option. See, this type of VAV units not used in residential building. I'm just giving the example, but these equipments are basically used in bigger commercial places. So it's a centralized system. So you have to draw duct. Okay. So what will happen, this type of system, what will happen, this type of system like placed it on near to the ceiling area, and actually it's connected somewhere outside of your building, not exactly inside, or maybe having some mechanical unit area where you will not having any disturbance. Okay, so it's connected in that manner, and there is two channel. One is the in and one is out. So basically, one will have uh, supplier and one is returned. So basically, what will happen in the VAV unit, in the supply unit, like the cold air will go from the blue channel, and whatever the odor or the hot air will comes from this return air supply. Okay, so there is two different. Now in the room, what will happen? Not room. Suppose this is VAV unit, then obviously you require a bigger hall or some bigger workshop, something like that. Then only this VAV unit will work. Okay. In generally in rooms in houses we will provide a split AC. So split AC is like having one unit inside and one exhaust is outside. So same way this split AC will also work, but it's like a separate system. But this VAB units, it's like industrial or mall or some workshop area. So there, this type of fixtures used. So I am just showing you the same things. Now, once you will place VAB units, you have to also place the diffuser. Diffuser means return and supply diffuser. So you have to place, it's quite big because it's not the residential type of uh, this type of diffuser basically used in commercial places. Okay, now this ducts, this diffuser is also should be at some certain height. Okay, now from this ducts, what will happen, you have to connect with this duct. So but you will not connect directly from this solid duct. You have to draw uh, flexible duct, draw flex duct and connect it from its center. Understood? Same way over here, draw flexible duct, or not draw directly this much distance. Draw duct. You should bring it little near, otherwise it's too big. Check it in 3D and you can see actually these are not properly connected because of the height issue. So maybe you have to bring little more, then it will be properly connected. Okay, understood? Actually, this is the residential house, but obviously in commercial places, this type of VAV units, you have to connect it in this manner. Also, right now I have drawn the like ducts manually, but what you can do, you can not need to provide all these ducts. What you can do, suppose you want this to be return supply. Okay, I'm just giving the example. Okay, don't take it like I'm showing it's wrong. Obviously, it's this is a residential project. You have to work this type of project in commercial places. Okay, select these two ducts, this two diffuser. So once you will select system, so we have any time option to connect into option available. So what type of connections you want first? Obviously, I want to connect with the supply, and I also want to select the let's draw at least few product. Select equipments. Okay. So anytime we can also generate like the same I have shown you in the plumbing. We can add the equipments and we can generate the layout. Okay. So what you have to do, you have to select this element and then you have to select the equipment. You have to select the equipment Now you have the options to generate layout. Until unless you will not connect the system from the equipment. How to connect you understood, like I will tell you again, no problem. Suppose this diffuser, same way the electrical I show you now. So this diffuser, you can select, you can select and you can click on duct. Okay. Then obviously these are supply diffuser. Okay. Then you can click on generate. So it will show you options, network, like how you can you do this type of connections. Okay. Or in this way you can connect. So these options you will get. Understood everyone? So these all three are right now in one system. So now what we have to do, we can select and we can generate layout. So you can see there is a T connection network. Then there is a parameter. So basically it's connected like that. Also in the settings, you can change main chain is duct system. The branch you can change to the flex duct so that when the branches will be takes place, obviously it will be flex duct. Okay. So whatever it will shoot you, like automatically it will try to draw. So I think this one is more suitable. Go in 3D, go in mechanical view. But before also you need to at least do some correction in the plan. Like right now, if you will not give proper spacing, then system will get confused. Like how exactly it will be like connected in this much congested area. So that's why the layout will be not takes place properly. Okay, generate. Now I guess it will be properly connected. Yeah, you see, no need to connect it from the our end. Just need to select. Okay. So all the ducts, once it's connected, generate layout. Now you can see the options are there. So I wanted something like this. Okay. Maybe after that also you need to do some changes, because if it's not connected, then it will be show open duct. Okay. So little practice you have to do so that it will connect properly. But once you will understand, you can do some of the correction. Like, see, automatic generation is there, but obviously sometimes it will not do properly. So you have to do it manually also few times. Okay. So I have just shown the representation. You can check it from the Google as well. So many things you can like HVAC. so that you will get the idea like how different projects have different types of ducts. You can see. So just see the images and you can start working on it. Okay, it's simple. Like one room, you can provide one diffuser, and then you can connect it from the VAV units. Okay, simple as that, right? Also, it will not clash so that you can see. Also, wherever we will provide the central duct, we require more ceiling height. So make sure, obviously in commercial places we have more height. So obviously we can easily work it on here. So bigger projects, it will be like lots of ducts and all. So everything will not clash. It will be clash free. So the ceiling height should be more. Now you can understand how this HVAC work. So those type of diagram is also shown. Every floor, the duct is there. At the top, see this type of buildings. In suppose in the apartments, suppose if the central AC is there, then it will be having air handling unit (AHU). Right now, I am showing the VAV unit. So VAV unit, it's like a floor on floor you have provided, and it is like just outside of the house or the commercial place. But but handling unit is also on the top of the roof. Okay, kind of chiller. So it's connected from the roof and connected to every part of the building. So that is AHU, air handling unit. Okay, supply air, return air. This is the AHU. It's outside. This one is also AHU. Okay, so it's on the roof generally, on the terrace. This is AHU. Sometimes it's on the ground as well. But in generally, if we have a space on the terrace, we'll provide it over there. Okay, hope you understand. See, only basics you have to learn. No need to go in that deep to learn the HVAC and plumbing, but basics, if at least you are knowing. So inside, sometime the inside in-house projects, you will get this type of work. So that time you can easily work it on easily. Suppose if you work in landscape architect, as a landscape architect, suppose you worked. So that sometimes you will get chances to work on irrigation pipes. Okay. Even in the architectural elements, sometimes you have to draw some of the pipes so that the MEP team will have at least the basic layouts, how you are providing so that they will get the idea. So sometimes you have to provide some basics layout diagrams, even there for the HVAC team also. Like if they will get confused for the routing, you don't want to disturb your building elements. So you can provide the routes from your end and they will work on it, the design part. Okay, like that it will work. Understood everyone? So this is for the MEP side. Hope you all have understood very well. But also I will provide the recordings for the session. So that's all for the today. See you in the next session. Thanks everyone. See you in the next session. Okay, bye.